Unit 2, Module 3, Session 2. We're multiplying by multiples of 10. This home connection might take you too long today. We'll find out. Name a number at the top, and let's begin. Multiple ways you can approach these problems. For instance, if I take just letter A, even though in your head you might be able to just take 2 times 16 and go, well, 16 plus 16, that's 12, carry the 1, bring it 3, 32. You're like, aha, I can do that pretty easily. Well, maybe you would prefer to take 16 times 2 and do the algorithm. 6 times 2 is 12, 2 times 1 is 2, plus 1 is 3. You get the same answer. Or maybe you would prefer to make the numbers friendly. Take it 2 times 10 and a 2 times 6, because 10 plus 6 is 16, right? 2 times 10 is 20, 6 times 2 is 12. Combine them, what do you get? 32 again, okay? Regardless of the way that you do it, you're going to get the same answer, but being flexible enough to try different ways is going to help you find the most efficient way, and that is super important. Why is it super important? Well, because it's not too bad 16 times 2 and you just add 16 plus 16. But if that was 16 times 19, you're not going to add 16 19 times. That's not efficient. You use a different method, okay? If you go on to letter B, for instance, 20 times 16, a couple different ways you could do it. You could stack it, right? Do the algorithm, 20 times 16. Make sure you carry the 0 when you do the second layer. If you know how to do that kind of multiplication, then you can just drop down the 0, do it that way. And that's sort of the method that I would recommend today. But think about this. 20 times 16. That is the same as taking 2 times 16, and whatever you do at the end, you just add a 0, okay? 2 times 16 is 32 with a 0 on the end. Makes it 320. That kind of method is going to be a little bit faster. You could break it apart and do 20 times 10 and 20 times 6 and then add them together and still get 320. It just takes more time. But if you have a number, if you know you're working with a 0, well, use our strategy for putting that 0 on the end of the number. Make it a little simpler, okay? For instance, letter D, 40 times 21. 40 times 21 is the same as 4 times 21 with a 0 on the end. What is 4 times 21? Well, we could do it this way. 21 times 4, that'd be 4. 4 times 2 is 8, 84. Okay? 84. With that 0 placed on the end. Your answer is 840. Okay? So if you see a 0, D, B, F, I would definitely try to use those. If you see a number that's not so friendly, maybe you could make it friendly. 4 times 20 plus 4 times 1. Okay? I'm going to give you an opportunity to work through those on your own time. Pause this video if you need to, okay? Section 2 says fill in the blanks. This is kind of an issue I've noticed, because when we see this equal sign, we're not thinking about how it has to be balanced perfectly. If you think of like the scales balance, maybe that you might do in science class, where you have this object holding up these 2 plates, and the plates have objects on them, and if they're even, well, then they don't, one's not higher than the other. If they're unbalanced, maybe your scale tips like this, because one side is heavier than the other. Well, when you have an equal sign, we know that both sides have to be identical. So I have 6 times 20. Do I care what 6 times 20 is? I do not at all. But what I do care is this here. I have a 6, I have a 6. We're good. I have a 20, and then I have a 2 times something. I have a 20 and a 2 times something. This 2 times something has to equal 20. 2 times what equals 20? 10. our equation is now perfectly balanced. It might not seem like it because this is 3 individual numbers and this is 2 numbers, but I have a 6, and technically if I take this 2 times 10, I do have the 20. This is now perfectly balanced. Same on this side. I have a 30 and an 8. Okay. 3 times something times 8. Okay, I have the 8. Let's just forget about that because that's balanced. But I need to figure out how to make 30 on this side. 3 times something is 30. 3 times 10 is 30. Okay? See how it is now perfectly balanced? I've got a 30 and an 8. I have a 30 and an 8. So when you go over to this side, I'm going to let you do these last two on your own. On this side of the equation, I've got a 10 times a 10, which is a 100. Okay? I'm just trying to figure out what's missing. On D, 40 and 7, here I've got a 10 and something. There's my 7. So I need to figure out how to make this part 40. Okay? Pause this video if you need to. In my multiples wheel, we're talking about multiples of 4. I'll zoom in so this is as big as it can possibly be. Okay? 4 times 2, 8. Oh, love that one. 4 times 20. Well, that should be the same as 4 times 2. But what did we add? We added a 0. Because if I got rid of that 2, they would look the same. 4 times 2 is 8. 4 times 2 is 8. But 4 times 20 is the 8 with a 0 added to the end. Okay? 4 times 3 is 12. 4 times 30, use the same idea. 4 times 3 is 12. But I have an extra 0. Place it on the end, 120. 4 times 6 is 24. 4 times 60, or 4 times 6, it's going to be the same. 4 times 6 is 24, with that extra 0 on the end. 9 times 4 is 36. Hopefully you can see where I'm going with this. 4 times 90 is going to be 36 with, with the 0 on the end. Sorry that my 6 doesn't look very much like a 6. There we go. Use your rules. Whenever you see those zeros, you can get rid of them just for a second to make the math easier, and then just place the 0 back on the end. Because counting by 90s is way harder than counting by 9s. If I count by 9s, I go 9, 18, 27, 36. If I count by 90s, I have to go 90, 180, 270, 360. There's a lot more opportunities to make a mistake if you count by the larger number. So if you see a 0, get rid of it for a second, and then put it back on when you're done. Okay? Oh, here we go. I might have to zoom out so you can read this with me. Kyra is putting up streamers for a party. She uses 75 feet of streamers to decorate one wall. 2 more walls also use 75 feet of streamers. Kyra cut 75 feet of streamers for the last wall, but this wall has a large poster on it, and she only needs to use 68 feet of streamers. How many feet of streamers did Kyra use in all? Well, if you want to think of walls in a room, we could draw it out, right? Maybe some sort of a square shape. She used 75 for one wall. 2 more walls used 75 feet. And then she cut 75 feet for this wall, but she said, nope, that's too much. She only needed 68. So how many feet of streamers did Kyra use in all? You could add 75, 75, 75, and 68. Or you could take, how many 75s are you going to count? You're going to count 75 3 times, and we can multiply it that way. 5 times 3 is 15, carry the 1. 7 times 3 is 21, plus 1 is 22. So there's 225 feet, okay, plus our 68 at the end. So we can take 225 plus 68, 8 plus 5, okay, carry the 1. 6 plus 2 plus 1, bring down the 2. Our total is going to be 293 feet. And I think I went kind of fast now that I'm thinking about it. Trust me, if you feel like I'm going too fast, you can slow me down in the settings by pressing the little gear and going to playback speed and turning me down to maybe like a half or 75%. But if you just want to try to solve these problems first, you can pause, so work it out, press play and then see if your answer matches mine. Challenge. Luis and Kyra are getting ready for the party. Luis makes 6 sheets of cookies. Each sheet has 13 cookies, so we have 6 of these, right? Think if is that 6? 1, 2, 3, 4, 5, 6 cookie sheets, and each one has 13 on it. Now, you could add these up, or you could multiply, right? We'll talk about that later. He also makes 4 trays of brownies. And each tray has 16 brownies on it. I like to draw it out. It helps me think. How many cookies and brownies did Luis make in all? We're going to combine all of these, okay? A couple ways you can do it. You could do the long addition and stack them all up. How many times do we count 13? 1, 2, 3, 4, 5, 6 times. 13 times 6, okay? How many times do you count 16? 4 times. 16 times 4. Whatever these two answers are, if you add them together, you should have a good total, okay? And I'm going to leave that up to you. I trust you. I believe you can figure this out. Pause this video. See what your answer is. Take it to school, check it with your teacher, and enjoy.